just to be clear, I'm an astrophysicist. I'm not uh, in the field of epidemiology or and so, but I use this kind of dynamical models for populations and astrophysics and in the fields of physics. I would like today just to share some experience from a model that we started to construct it 3 months ago. Or 2 months ago actually, and the idea was to revisit the SIR models and apply to Brazil, because in fact we understand that Brazilian community was a little bit slowly, and the problem of the scientific focus of the coronavirus, and our main idea was preparing some simulations to show to show people in general the ongoing virus from Europe, and that is coming to Brazil very fast. So, and around February, late February, we started to send our first results to a blog, just to the media. I mean, so it's open media, and that's coming a lot of attention. So in this meantime, we write the paper that I'll show here, and I would like to figure out my collaborators here. So Vladimir Lira is also an astronomer from New Mexico University. Jaber is a epidemiologist from Syria. I mean, from Tunisia, but he works in US too. Leandro is my student, my PhD student, that is really connected to Python model and all this. I mean, connectivity from models. Pedro is also a doctor from São Paulo Hospital, and Ion is also from epidemiology side. Ricardo Valentim is from data analysis and is another professor from the Federal University of Rio Grande do Norte, that put in line a big data set for Brazil in the Northeast. And Kenio too is from is a doctor from the UFRN, and work with the question of the old people in the epidemiology issues. So this is not stuff. It's a old stuff. We can say that people look at this distribution and how the distribution translate in time from long time ago. So this is a very nice cartoon from the milestones of the influenza pandemic problem. And in the right slide, I show you this milestone paper from Kemark and Mike Kendrick. That is the basis of all these SRR codes that we talked this morning. And people here is really connected with this paper. So thinking about the problem from Brazil, I'll be more specific from here in the Northeast. The Northeast is this part of Brazil that is exactly here as shown in this plot. Natal, it's around here. We have this is the Rio Grande do Norte state. So I'm really concentrate in talk about the questions about the Northeast of Brazil for several reasons. First of all, is because we have a very different, I mean, science perception from the South. And here in this slide, we can see the actual COVID project that show in real time all the data from the COVID-19 in Brazil and the Northeast mainly. So this is a very nice tool that Ricardo Valentim from University Federal of Rio Grande do Norte put online. And actually, that is the major data set that we use it to run our simulator. So the COVID has a lot of nice data, so you can go online and have these basic statistics. You have this trend of dead and positive tests. We have some stratification by geographical stratification of the problem. We can see a lot of local data. That is very important for this message from the models to the people that acting in in the governors and that make a difference in the decision side of the pandemic. So coming for the models, one of the the part of the site is connected with projections. In the projections, we have two important things. One is the mobility of the Brazil, the mobility of the Rio Grande do Norte state. And that is important to see the level of lockdown and the mitigation and all this empirical data that we need to the models. And in the same side of this mobilization trends, we have this projection from the SR model, that is model that I will use, and I will talk a little bit more about that. So here is our paper frontal page. So we can see here the title, and as you see, we are more concerned, we're more focused on the question of the age stratification and the ideas about the vertical lockdown and confinement in Brazil. The reason is simple. The Brazilian government tried to put in a kind of strategy to facing the epidemic, a kind of vertical strategy in Brazil, and that's make a lot of attention in the media. So we did this model in between other reasons to put to the people how bad is this idea. So that is one of our, one of points that I will stress it here. So as our model, it's very well known. So people show this today. We have few difference between the SIR and the SEIHAR. So combination of the kind of compartments that you use give different models. So actually we use a situation that is more connected with this SEIHAR model. And in this model, we use exactly the same prescription, the same classic prescription, but the diet is our first parameter is very important here, because in Brazil, the number of tests is really below the minimum that you can say something to trust the numbers. So in my models, we put special attention to feed things taking in first consideration the dead numbers. So that is important to say here, because we figure out that for Brazil in general, the number of under notifications is very, very high. So say that, I will spend some few words about the mosaic. We call this mosaic, that is epidemic infectious disease of large population code. That is a classical code that we put in online access. Is an open source. So you have susceptible compartments, infected compartments. You have these asymptotic compartments, and people remove it is also, of course, there. And the model could be run in an online tool, and you can do measurements by a online platform that is in the website from the UFRN. So the equations, it's kind of classical equations from the dynamical models. So here it's the bench of equations, and the right side will have the connection between the model and all these beta, gamma, and all these parameters that you need to turn around and solve solutions in real time. So an important point to be stressed here that we use a formulation that is very usual in astrophysics, that is Monte Carlo chain Markov method. So from 10 data of deaths, we can run the Markov channel and feed the best model for this local dynamics. So that is a very, very important thing when we have this ongoing process, and we need to get results in the same time and come back to the data and run again. So that is life is changing when we use this Markov chain Monte Carlo process. So I have several reasons to put here and why we use this MCMC method. But the main reason is that we can figure out how the out of the model is affected by the input data. So this is important because all these models have the problem to converge in the first part of the data. So in Brazil, for example, in the northeast now, we need very fast results to drive decision from the government, to drive decision for the community, and to say something about the confidence if the lockdown is useful or not for a specific a community. So showing in some parameters from our model, we can say that this is the major parameter that we deliver with this model, and we have this kind of table for each state and each region in Brazil. So the idea is take this, I mean, I can say average time for the incubation time, for the time for infection, so symptomatic fractions. So all these group of parameters are delivered for each state, as I said. One of the results that it's spotlight in our paper, it's the stratification of hospitalization, of fatalities, and all these numbers in divided by age. So that is important because for senior people take more time in the hospitalization than a 48 years old, for example. So that is sometimes not realized from the governors and for the people that use the models to keep the direction of actions. Concerning the simulation that we did, here's what looks like our models. So we have for RN is Rio Grande do Norte, it's the state that I am from. And we have the population, we have the hospitalization plot, and we have the cumulative plot. So these three plots are the major plots to understand the dynamics of a specific population. Here, in population, for example, we can figure out the peak, and we can inform the peak of symptomatic people and the exposed people to drive actions. And the second plot is important too because we have the growth of cases, and we can put lines. These lines represents the critical point when the hospitalization is upper the limitation of beds in the state. So that is very important when we do this kind of models to say something. For example, when in time the hospitalization will be higher pressure or be, it's I mean the limit of critical between a bottleneck in the hospitalization time. And here is a classical plot with the death numbers from Rio Grande do Norte. This is the black point. The model fits, in fact, the strategy of the model is fit first this data. And after that, we have the solution of the hospitalization, that is the blue line here, and the symptoms, that is, of course, a lot higher than the tested population. So we did for Brazil too. So this is our plot for Brazil. And actually, we can say that the peak of exposition is around June, and can expect it, if you trust in the numbers today, that we have this kind of dynamics for the Brazilian population for the next months. So in Brazil, we can see here and a very solid line in the tested. That is not bad. And you can figure out that the exams are a little bit higher than the hospitalization. The difference between the numbers of positive examined people and hospitalization is because some people are asymptomatic and are not hospitalized. So that is a very, very robust result that we can see in this plot. So talking again about Rio Grande do Norte, about my state and my home state, I can show in these two plots some important things. The lockdown here that I put in this projection in this plot is when the classes was closed. I mean, all the schools in the state was closed by a governor decree. And we can see in here is the same plot, but in a little bit different zoom, and we can see exactly how the decision that was did before the first that affected the tendency of the state. So this kind of model and this kind of situation is very important to say to people and to understand how good are the decision make before the epidemic peak. Here again, we are using a model to compare tendency in the northeast of Brazil. In the first plot, to have case numbers. In the second one, the dead numbers in function of time. And here you can see different states in Brazil. So this plot figure out how difficult it's to talk about cumulative cases, positive cases, and in reason, in the simple reason, these cases are underestimated and biased by the limited number of exams. So that is one reason why we use in our analysis the dead cases. And here you can see for the Rio Grande do Norte state, that is the blue line. So we can say actually that the Rio Grande do Norte and also Pernambuco has the same tendency in number of that. Sorry, Rio Grande do Norte and Bahia has more or less the same tendency, and Ceará and Pernambuco has a very, very high rate of that in the actual situation of COVID in northeast of Brazil. Finally, I move on for another plot that said the same thing, is exactly the same thing that I showed before, but here I just put things in a not logarithmic situation, because it's important to the governor and to the people, to the general people, realize it how the lockdown affected the distribution. So here it's the same numbers. I mean, it's dead numbers and the data of these dead comings, and we can see exactly six days after this close of the schools decree affected exactly the ongoing tendency in the Rio Grande do Norte state. So that is a very important how to say plot to communicate to the people from the state to keep this lockdown and to keep the things going. And this has a real action in the future of the epidemic in our state. Finally, I will put here my conclusions. I would say that a few words about the Northeast, and from this kind of study, we can plot. This is a report from a recent paper from Rafael and collaborators that use this kind of simulations, and we can say for all the states from the Northeast, where and when in time will be the bottleneck of the hospitalization. So I think this is a very important information now. Of course, models, more sophisticated models are exist and are important too. But here I talk about this kind of useful models that can drive decision, that can make difference in the government, that can keep a real impact of the situation of the COVID in the Northeast and in all these areas that are not really connected with groups and with people that do this kind of science. So, and a second message that I can draw today is about the vertical lockdown. So now we're fighting with the media to say that this vertical lockdown is a very dangerous idea, and that is not working at all. So I think this is very important to be said. I mean, to be repeated in Brazil, because the president has this idea that just keeping the old people at home can can be a good idea. And of course, the economic pressure is too high. And if the scientists say nothing, this will be the idea for the next days in Brazil. So also, and this I think is a good mention to be brought today. So keeping things going, that is my idea for these next days. And keep in mind too that all these models are wrong. However, some are useful. So that is more or less the situation that I can see in several parts of the world. I'm in Boston now, and here in Boston, I can read in the media a lot of press and press attention to say that models are wrong, because I have a lot of the economic pressure to say that science is not good, this kind of things. And in Brazil, this is very important. So it's important in this kind of meeting at the end say a few words about how important our model to keep this decision in a good way, and to say that these affect the real life in this pandemic situation. So that is my message today. So thank you, and I'm here for questions.
Okay, thank you, Zadias, again for your talk. I think that you leave a very important message. I would ask you about your last message about the models. Uh, uh, if it's possible now to know how wrong are the models, in the sense that, for example, when you forecast 200 infected people or more than this, and how you can measure the distance between simulations and the real situation.
That's a good point. So for Brazil, I mean, the robustness of data is fundamental. Bad data give bad simulation. That's a true message. And for Brazil, I think the only number that we have that we can use more or less in a good way is the death number. So I saw today some reports from these non-governmental people that say that in Brazil, more or less 10% to 15% of the numbers are low estimated. So I did some simulations just adding extra numbers to the data. And in fact, this affects a lot the epidemic peak. So I think comparing the rate, the growth rating of these numbers, we can estimate more or less how far we are from the reality. So we can do that in the kind of situation that we can add more that than we see in the numbers, and see how this affect the peak. And I think that is the only situation, I mean, is the only possibility to figure out how far we are. Another number that is important is the rate between dead people and the tests. So this is this is a fixed rate in Brazil and in other situations the same. I mean, we did the same from Italy and the same to the France. And the rate between this curve and this third one, that is the total number, is more or less the same. For example, when the first data arrived, we have 5,000 of infected. That is a more constant number for COVID-19. So this relation between this number could say something about how wrong or how far we are from the reality. And I think this is a very ongoing science, because we need in Brazil, in case we need this number to figure out how good we are in the official numbers that are delivered by the government. Of course, if you go to France, I did the same for France and for other countries, and the reality is completely different. And in Brazil now, my major point it's really send this message to the government and try to figure out how far we are from the reality. And yeah, so to say that the only thing that I can say is that need to figure out how good are the proportion between infected numbers and the died numbers. That is a kind of test of coherence of a final test for the models and for the data that are delivered.
I have a question. Jose, very nice speak, very nice data you have. I wonder what are your thoughts about the possibility of a second wave? And if you have, it probably will have a second wave of infection that may probably come with a different lethality rates. And that may happen because natural selection is acting, and some important governments of large populations, including ourselves, United States, part of Europe, and part of Middle East, are not controlling so severely the cases which may be spreading more aggressive strains of the virus. So we eventually can come, like in the influenza, you started your talk, with a second wave attacking a large proportion of young and healthy people, and that will change the lethality. Are you planning to do some scenarios on that?
Yeah, sure. Well, good question too. I didn't show one kind of projection that we did for few countries. That is cases, a number of that again, and I projected here a Gaussian from the scenario from the first part of the series. So with this, we can see the peak of the a worst scenario, a bad scenario, or a good one. So I try to how to say I try to say when I expected this peak, and this is for France and this for Brazil. This is numbers from today. This is online too, so too also. And for the second wave in this kind of diagram is very interesting because we can figure out the first wave that's coming when the process finish, okay? And if the France is coming in this process, so we can figure out for France in a few days if the second wave coming. So that kind of projections can say about the second wave arriving. So I did the same. I have not the plot here, unfortunately, but I did the same for China. And in case we can see the second wave that's just coming. And the age stratification of the second age is a fact. I don't know how good are data to take some conclusions, some real conclusions, but yeah, the age stratification is different in the second wave. So I don't know if papers come in the next day, but yeah, I think the tools that we push now, it's possible to be used in this direction too.
Thanks.
I just have another question from YouTube. Let me ask you, Ted. Ted is asking, could you talk a little bit about subnotification and how this could change the projections? We know that we have a very strong underreporting in Brazil, and the question from Ted is basically about this.
Well, that is so important too, because in Brazil, like Tunisia or India or some countries underdeveloped, poor countries, will have this subnotification. That's a fact, and people talk about, and it's very very hard to say how much undernotified are countries. And we try to generate plots from different countries to figure out how to do that. And for Brazil, for example, from Rio Grande do Norte, I have few things that I can show. For example, here in the Rio Grande do Norte curve, we have the dads that's at this moment. I have the impression that the data has come down with time. So now I know that this is not true, and that is because the test at this time in Rio Grande do Norte was less possible. And the same thing is here. You can see that the test coming. So it's natural that here you have a jump because in the epidemic first moment have tested, but I mean, and tests are not in a good routine, and tests just coming, boop, jump here and coming. So, but here we have a really under notification of the regular series of tests. So the fact that these points cross the hospitalization line is a signature of under notifications in test of positive infected group. And I think this kind of signature is one of the possibility to see how far we are in the under notification and in the Brazil and the Northeast and wherever in the world. But that is an important question. And so I don't know exactly how measure that. And now it's almost clear for Brazil that we need to solve this problem and say something to the governor, to the ONG, all the people, to show how far we are from these numbers. To give an example, I start to look at for some series from pneumological problems, fatal problems in the Brazil from the next year. The number is completely different from this year. So general pneumological problem that was keeping as a died cause is this year a lot of more important than last year. So of course, the difference in numbers is because people just, without testing, just say general pneumological problems. So this kind of situation will be a dramatic scenario for the next years in countries like Brazil, and probably India and some African countries too. So that is, it's an important question that could be for sure a central point to be focused on the SEIHAR models in the next months and next years.
Okay, more questions? If there are not more questions, I thank you again.
Sebastian Gonçalves.
Sebastian? Sebastian, your microphone is mute.
Okay. Can you hear me?
Yeah.
Jose, I have a question about the slide number 23. About the, I think it's the 23. No, it's the projection of states, Rio Grande, Ceará, and.
Okay,
yeah,
good.
22.
Yeah, here you go.
No, just I mean about the R0 numbers which are there.
Sorry?
Because you have numbers which are below 1, and there is no apparently no clear correlation between this number and the tendency of these accumulated cases a long time.
Numbers, you say, I mean, that is accumulated for different states, okay? And yes, this is one case a day, right? One case a day.
I mean, I'm talking about the left.
Okay, left. Good. So the left is positive examined cases, and your question is numbers below 1. Oh, okay.
No,
yeah.
Okay.
You talk about R0. Okay, Bahia. Bahia, the situation is dramatic about data. So this probably this is in an exam plot. The Bahia, I know because I talked this morning with Sergio Rezende that was here and other people from Bahia. We was in another meeting before, and the guys from Bahia say that the numbers in Bahia are really bad in the exams. So probably the low numbers in Bahia here is not real. It's affected by the number of exams that Bahia did, and the same in the first part of the problem. The same thing is from Ceará, probably in this part of the series. So I figure out that this R0 it's really affected by the number of the exams that's ongoing. So,
but I mean, my question is that you cannot have an R naught number which is below 1. I mean, this is the point. I mean, maybe this.
Yeah. I need the in my prescriptions numbers changing in 1, right? It's 1 is below 1 or higher than 1, but I put 1 as my critical point to say in my tendency, if you are in a grow up in a grow down situation. So that is my definition of R0.
So it's not the standard definition of R naught.
Yeah.
Okay.
So sorry.
Okay. No problem.
Okay, guys. I message you the link. We will start. Everyone received the link to the Zoom room. We will start at 2 p.m. Brazilian time or 5 p.m. UTC. Okay. Thank you very much again, all the speakers. And I think that we have a very important message from China and Israel about the restrictions measures that they implemented in those countries. China is a very good example and of the rapid action of the government when closed all the province and start a lot of different actions of prevention, but of also care, not only health, constructing hospitals, but also supporting people in very different actions. And from Israel, you know about the action of the government, and also the very important from China and from Israel, the very important actions from the scientific community, and the scientific community putting together, gathering some people from very different areas. I think that this is a very important lesson too. From models, I think that the models from Sebastian and Zadias, they showed different scenarios. I think that the different scenarios can show us what can happen, and I think that show us also that some important measures of restrictions of isolation they are very important. Okay, guys, thank you again, and see you soon. Okay, have a good break. For us in Brazil, it's lunchtime, and I think for someone asked it in YouTube if you would have a coffee break, for some people maybe it's coffee break. For other people, is for people in China, it's time for dinner or suppers. Okay, thank you very much again. See you soon.